Okay, I think we're back. All right, I did get the printer running over here. Um, Nothing we did as far as installing it seemed to be the problem. I think the only problem was I just could not get the Big Tree Tech. Big Tree Tech is the company that made that board. And I assume the screen over here, if I can get it. There, well, you can't really, it's all glare. But anyway, the screen. And I couldn't get their firmware from here, from their GitHub page. I couldn't get it to work. I'm not sure that I had the most recent version, though. It says that they have one that came out last month. So I might try it again just to do it. But what I ended up doing is the same thing I did before. I went to the TH3D unified firmware, and I used their firmware. Now there is a difference. So this firmware, well, this firmware right here, all these that end in .bin, B-I-N, those you just put on an SD card. Like I could just download this, put it on an SD card, put the SD card in the printer, and that would upload the firmware. The TH3D, now we do have to make the distinction now that we're on the 32-bit board, so we don't need the same process we did last time we put firmware onto this printer with the 8-bit board, where we had to open up Arduino, we had to do the bootloader thing, all that kind of stuff. You don't do that with the 32-bit board. So in fact, they've got this, if you have a 32-bit board or one supported by Unified 2, checkout, blah, 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 go here. So we went to this one, and somewhere in here is the download for it. Oh, let's see, I used this one. Creality Ender 3 SKR E3 mini board. So that's the board that we have, and Ender 3. So I used this firmware. This is not pre-compiled. So, and this is what you, if you ever want to change something other than just put a pre-compiled firmware on your printer that someone else has put together, you're going to have to go one of these type routes. Now you can do that with this. They do have an uncompiled version here in this Marlin folder, and it's got all of the files that you would need to edit, like we did with the other 8-bit version. So anyway, I downloaded this. Well, no, this one with the E3 mini board, and then instead of opening this in Arduino, what you have to do is you have to open that in Visual Studio. I used Visual Studio Code. I didn't use full-blown Visual Studio, but I downloaded, or I already had, but you would probably need to download Visual Studio Code, for whatever operating system you're using. I was using Windows. So download that, and that brings you to, let's see if I can find it. I have it open somewhere. Thought I had it. Oh, there it is. To this. So it starts out, I don't know how, exactly what windows will open when you first open it or not, but it probably starts with some splash screen, and this is probably not there. You're probably not, well, you wouldn't already be looking at configuration.h. What you would need to do is first go to this little section with these, it says extensions, but it's these little blocks, and one of them's kind of coming in to form this other block. And you would probably have the C++ one there, but that's probably the only one that you would already have. So you would need to install, well, you'd need to install Platformio or Platform.io IDE, and all you do is you search for them, Platform.io. I always said it Platformio, but there's a .io extension, so I don't know if it's actually Platform.io or Platformio. Anyway, you get that one. You need the IDE. And then that technically is enough, but this auto build Marlin makes things so much simpler. Marlin is the, I don't know if I've specifically said that before, but Marlin is the brand, or not brand, but the base level firmware that we're running on this printer. There are other firmware that are not called Marlin, but most of them are going to be Marlin. It's open source, and it's one of the older ones, if not I don't know if it's the oldest firmware, but it's one of the older ones. It's well developed and it's well maintained. And then other companies will take Marlin, this kind of open source version, and put their spin on top of it. So the unified firmware that we've been using from TH3D, it's Marlin at its core, and then they have rearranged things and made it their own. And this thing from Big Tree Tech that we downloaded, that's Marlin. It's just already configured to should work with their board and their printer. There are some others out there, but most of the time, unless you get really you have a specific idea in mind, you're probably going to end up being working with Marlin. And so this auto build Marlin makes things much simpler. So those are the only three I have, because that's really the only three that you need for working with printers. Now, well, you don't even really need this one. It just comes, it's already there. So you need auto build Marlin to make things simpler, and you need the platform IO IDE just to be able to compile the code. All right, so you do that. You downloaded, well, let's see. You downloaded one of these packages of firmware, and then you open it. You open the firmware in here. So you go to File. You actually open an entire folder. So open folder, and then you navigate to wherever this you've downloaded. It'll download as a zip. You extract it, and then there's firmware Marlin. I think this is the the right path. And you open that entire folder. And so then I have, it would look more or less like this is what you would end up with. It would have all of the things in that folder. There are several folders when you download it that might have the word Marlin in it or might have firmware. If you open one and then you click on this button down at the bottom, Auto Build Marlin, it will either say Marlin firmware is open in the workspace, blah, blah, blah. That's a good sign. If it says that it is not open, I don't remember the exact error, the wording of the error, but it'll say something along the lines that it can't find Marlin firmware to do its thing with. And if that's the case, what that means is that you have opened the wrong folder. So go back, close the folder you have open, and open a new folder, and either go up a level or down a level until it is the right folder. It should be the one that has Marlin in it, not the one that shows the source and all that, but the one that has Marlin listed there. But you know, maybe your folder configurations are a little bit different or something for the firmware that you download. But when you click on the Auto Build Marlin icon after you've installed that extension, hopefully it says Marlin firmware is open. That means it sees what it needs to see to be able to do its job. So that's kind of the first steps. Then the rest of it, once you do that, once you get it set up, you don't ever have to change anything at that point. Then you can go over to your file manager. There's configuration.h, or well, what do they call this? The Explorer. So configuration.h, the advanced is that there. There's actually boot screens in there. The back end is in there if you really want to get into some of the details of the firmware. But most all that you need to do is configuration.h. Now it is slightly different than the one that we put on before for the 8-bit board, but it works almost exactly the same, where there are multiple printers already kind of set up in here, and you pick the one that you want. So since we would go to the top up here, we would Control F to find an Ender 3, and then we would look through the Ender 3 options. Well, let's see. These are the Ender 3 specific options. Oh, it doesn't have a space. There we go. Or maybe it doesn't. There's originally this was commented out. So originally this was, commented out. You find, oh, okay, there's Ender 3 SKR E3 Mini. So that's a little bit different than it was before. This firmware that they have here is specifically made to work with the SKR 32-bit board that we put into the printer. So we would uncomment that. The other one here is Ender 5, so these are the Creality printer section. Then you pick which board you actually have, which version of the board. We had the 2.0 version, so we uncommented that. We did want to use the BO Touch, so we uncommented that it's a custom probe. They do have their probe mounts in there also, if you have their Easy Able system, so you would uncomment which one is appropriate there. I think there's one more thing to uncomment. Maybe that's just those two and the probe options. Oh, and then you have to go in and actually put in your numbers for that custom probe offset. These should be the exact same numbers that you used the first time, where we put the paper down and we measured where the nozzle was, and we measured where the probe of the BO Touch, the tip of that was, and we measured the X distance between those points and the Y distance between those points. And for us, it was -43 and -7 based on their arrangement of where's positive and where's negative. And so I used those exact same numbers from the first time we did it. Then there shouldn't be any other thing that you need to change. There are other things you can change. Linear advance is one thing that we'll look at. Oh, here's the other thing. Define BO Touch. We needed to actually uncomment those because we were using BO Touch on this pin. So we did have to uncomment that. Linear advance is set to 0 right now, so that means it's inactive. We will probably do that later. What this does is it lets the printer predict when it's coming to a need to change direction or a new line or whatever, and it can kind of control any blobs that you might have. If you've noticed on some of your prints, every time it starts a new line, a new layer, there might be a little blob there. In fact, in Cura, there's an option to align the Z-seam in certain directions so that those blobs all line up, or they get hidden on a corner, or things like that. Linear Advance kind of helps remove those entirely, so that there's this prediction about, all right, I'm coming to the end of a line, I'm going to slow down the extrusion rate here, or maybe stop it entirely, so that the oozing that's going to occur when I lift the nozzle up and go to the next layer and all that, I kind of account for it. The 8-bit boards have I don't even know if it's possible for them to do that amount of processing on the fly. I've never seen one do that, and maybe it can, but the 32-bit boards can do that. And so, but you have to calibrate it. I haven't calibrated that yet, so it's set to 0 right now. But there could be another term here, another number here that would let us calibrate that, and we'll do that later. There's a print that you have to print, or well, the easiest way is there's a print, and it gives kind of like the one where we did this. It gives you some different options, and you pick the best one. There's the manual mesh leveling. I turned that off. You could enable that if you wanted to, so that you could get your mesh really fine. You know, a lot of points on it, and defined that. That wouldn't be a bad idea on our printer, because we do have the solid mounts, and so it shouldn't change that much. I don't know that I want to do that yet, because I'm switching between at least two different build surfaces. Sometimes I have, well, where are we at? Sometimes I have this guy on there. That's the one we've been printing on. Right now, I've got a glass bed from Creality on there. This glass textured bed, or well, the one with all the little dots on it. I've got it on there right now because we're going to look at printing TPU, and I didn't want to print TPU straight on this PEI. Whoa, wow, that blew out the whole screen. The TPU on the PEI sheet. So I put this bed on there, and they're different thicknesses and probably different levels of flatness. So what I'm doing is probing before every print still. But if you think the probing is taking too long and you just want to do it, you know, ever so often with a lot more points, then you might want to go enable manual mesh leveling and go that route. And it wouldn't hurt to enable the thing. All you do is you erase those two slash marks, and then it's an option in your printer. Before, with the 8-bit board, they were limited on the amount of memory on the board, and so you had to be careful about turning on too many options. You just couldn't compile it and fit it onto the memory of the board. 32-bit boards have a lot more memory, and you don't have to be quite as concerned if you're going to have everything fit on the board or not. So we could just have it on there if we wanted it. You pick all your options. So whatever all the options are that you want to work with, you pick those. Maybe there's some in the advanced menu that you want to change. Maybe not. Different temperature sensors, so maybe you change out the hot end and it's got a different thermistor in it. Whatever you change. You get all that set the way you want it. Then you go into the auto build Marlin. And there is this button up here that looks like a hammer. There's one that is upload. I don't think it's a good idea. It may not even be possible to upload the firmware to the 32-bit board with the SD. Well, not with the SD, with the USB cable. So I've not actually tried that. I don't think that would work. But you go to the little hammer icon, and this is now the auto build. So without the auto build, you had to do all of this yourself. In this case, there are 4 different environments that it can build with. There's one that's the Big Tree Tech, one that's got 512K memory, one that you're going to do over USB, and then the 512K over USB. I just did the 512K as if I'm going to create a file, put it on an SD card, and load it onto the printer. I haven't done these USB ones, and I don't know. I mean, they're there, so maybe they do work, but I haven't done them. So you click build. It does take a while. Maybe in the, I don't know, close to 10-minute range, 5 to 10 minute range to build. But once you build it, all of the options that you created in the configuration files, they are compiled into a firmware. So you click on this little folder, and over here it opened. Now, one little bug with this is if you have a file called firmware.bin maybe sitting on the desktop or in a higher level folder, it'll find that one for some reason. So I did have a firmware.bin sitting on the desktop from the last time, so I just moved that one off the desktop. Otherwise, you have to go dig for this. The idea is you click on this little folder icon, and it pulls up where it stored the newly built firmware.bin file. So here it is for me. You check the time on it, make sure it's the one that you just did upload, because if you do this often, you might end up with lots of these firmware.bin scattered all over the place. And so you do check the time and date, make sure that this is the actual one you just compiled. And all you do is you copy firmware.bin onto an SD card, put the SD card in the printer. Now we're at this file right here is at the same level as what we did back here, where we just downloaded one and called it firmware.bin. So it's the same idea, just we went and compiled it ourselves. Well, the program compiled it for us after we set our options. Put that on the SD card, load that into the printer, turn the printer on, and it will take a couple of seconds to boot up more than it normally does. And then you go in and you have new firmware on your printer. And then on that SD card, this file, to check that it actually got put onto the printer, you look at the SD card, and it should be all caps firmware.cur. So it's like the current firmware. I don't know if that's what CUR actually stands for. That's just what I imagine it stands for. And let me let this dog out because it's making a bunch of noise. All right, back. And then that will tell you that the firmware at least got off of the SD card onto the printer and then renamed on the SD card, and that should complete the process. that doesn't change any of this firmware. If you want to ever go back to it, you just copy this firmware, put it on the SD card, rename it to firmware.bin. You can't rename the firmware.cur. I don't think you can rename that one on the SD card. I haven't tried that, but I don't think that would work. It might. This firmware.bin should always take those options that you had and put them back onto the printer. That's a nice thing about it. You don't have to try and recreate the options. They're all stored in here. Anytime you want to go back to that state, you just copy this file onto the SD card and turn the printer on. So you could have several of these that you could switch out pretty easily. You know, it doesn't take very long if you have certain things you want to print under one condition, and then you want to change those firmware options under another condition. You could just easily have multiple firmware.bin files and put the one that you want on the SD card. All right, so we did, I think that was the only thing. All of the connections and everything that we did last time seemed to work fine. I did go and mount, let's see if we can get over here to the panel so you can actually see it. It's kind of got a glare on it. All I did to mount this is there's 2 screws here. I unscrewed those, and on the back there's 4 screws. Unscrewed the old panel. This is what it looks like, and there were 4 screws and 1 plug. I think it was 3. Unscrewed this one. The other one screwed directly in its place. Now, I don't know if y'all can tell on the screen or not because of the glare. I don't know if I can get it in a position where there's not, maybe sort of like that. It doesn't quite fit exactly. Like the offset of the screen is off to the right a little bit. So it's a little annoying because it's not perfect, but it fit fine. The screw holes lined up and everything like that, they were fine. And now it's a touch panel, you know, so that's nice. And it has a regular size SD card and a USB slot. And even there's a light on the LED or on the knob that somewhere in here you can change. I think it's in custom. Let's see. Nope, not custom. Settings maybe. So rotary knob LED, you can change it to different colors. I don't know if you can tell on the screen, but this knob is, yeah, you can kind of see. I had it on blue. There we go. So just for, I don't know, doesn't do anything. It's just kind of fun. There are a lot of options built into here. You even have the option to write G-code. Oh, wow, you can't see that. I don't know how to. Nope, that made it worse. Well, it does have, there you can kind of start to see the exposure is just so bright on it. If I turn that down. All right, you can write G-code commands. Now it's limited, you know, in the character set that you actually have to work with, but you can write G-code directly on the LCD. Like if I wanted to store the settings, I could write M500 and send that. And it would store whatever settings I have in there. Hopefully I didn't store anything I didn't want. Maybe G28, I want it to home. And you can't hear it, but it's over here doing the homing routine. Get back into where we can see what's going on here. So you can actually send G-code commands right on the printer if that's something that you want to do. I'll let it finish that before I exit out of the little deal. And you can actually see our BO Touch is working. Let's get going. I've got it on the slower probing mode. There is a faster one that we can set in the firmware, but it's on the slower one right now. So you could do that. Let's go back to the screen here. If you hold down the button, you can switch to Marlin, what's called Marlin mode, and that's the it's a emulation of the LCD screen. If there's something in the LCD screen that you need to work, it's got the same, you know, maybe you just want it to work like the LCD screen. You don't want the touch screen or anything like that. Or maybe there's a particular setting in here that you need to get to. So it's all of that is just the way it was before. And then to get back, you hold down and go back to the touch mode. So it's a nice thing. It is. It's slightly concerning that I couldn't get the firmware from the company that sold the board and the screen to work, but I did get other firmware to work. So I don't know. I don't know why their firmware didn't work. It did compile and it did load and everything. Well, I used a pre-compiled version, but it never worked with the BL Touch. And when you would boot up the printer, there were several errors on the screen. I don't know, it was doing something out of order. So I just used this other firmware. Here you can see the bed. I've just got this bed. It's not magnetic, so it's just held on with a binder clip in the front and a larger one in the back because that's what I've had on hand. And now everything works pretty much the way it did before, except that it's running a 32-bit processor, so curves are calculated a little bit faster than they were before. So if I was having maybe some blobs or whatever around really complicated compound curves, this should eliminate that. It is quieter when printing. We haven't looked at that yet, but we'll look at that in a second. Right now, it's at the upper 50, and that's really just the fan when that's me talking. But the fan is making most of the noise at the moment. And this is about where it was before. You know, the fan's no different. But when it was printing before, it got to, let me see, I wrote it down. It was in the mid 60s, upper 60s when it was printing, and it shouldn't be any louder than it is right now when it's printing. We'll print something in a second just to see. I'll leave this on. Well, let's put it back on the fast mode because that's what it was on last time. So the more racket I make, the more it picks it up. Anyway, the other thing we were going to do today is we were going to look at printing with flexible materials. So this is quite possibly the ugliest print I've ever made, but just because of the colors. But I printed this. Let's see if we can get our exposure to not. Wow, it's just so bright out here. Maybe if I turn this off. No, that makes it worse. The middle part is just regular PLA. It's the PLA we've been using, that 3D Solutech PLA. It's kind of raggedy around the edges because it's actually two parts, and it did have a rim over here that I cut off because I glued it together thinking that I would be able to just, this would be flexible enough to, it is flexible, but it's still kind of rigid. You know, it's pretty stiff. There are different, that's the first thing to know about printing with flexible filament, is that there are different levels of shore hardness for different filaments. The stiffer ones are going to work better in this style printer with the Bowden tube. If you have a direct drive printer like this guy, where the feeder is sitting right on top of the hot end and there's essentially no unconstrained path between where the filament comes in and where it comes out, it's all constrained, then that's going to work better with the really soft filament, the Ninja Flex, and there are brands that are very rubbery, very soft. That's going to work better in this style printer. Oh, lagged out for a second there. The ones that have the tube, the Bowden tube feeding it, are they might be able to print the softer stuff, but you're going to have to go really slow. You're definitely going to have to, or most likely going to have to turn off any kind of retraction, and just basically print things slowly to get the softer stuff. Now this one, I actually have retraction on, printing at 50 millimeters per second, which is about the same speed I normally print just PLA. But the filament is a lot more rigid. Now you can control even this. Now look, I've got some delaminating right there. You can control the flexibility even among the print by the number of walls that you use and the infill. So fewer walls, less infill will make it softer. This one has, let me check, I don't remember. This is it right here. It has 2 walls and 4 top and bottom layers. So we could reduce the top and bottom layers to maybe 3 or 2. Walls, I don't know if you'd want to go to 1 wall. That would be a good chance for it to delaminate even more. I do have the infill pretty low at 10%. It's printing a little bit hotter than we print the PLA, but that 230-ish range is about right for most flexible materials. But there's the print speed is at 50. I think I print PLA at like maybe 55. So PLA could probably go a lot faster than that, but I've never been in that big a hurry. Let's see. Retraction is enabled. Although this particular print, where's it at? Probably doesn't have any need to retract at all anyway. But you can see where got a little bit of delaminating there. And part of that's because I've been, squeezing on it like this. Let's see what else. I did have a skirt just so that it had a little purge line. I printed, you can kind of see where I had a little bit of glue stick here. I don't know that I needed that, but this is TPU, so it's a thermopolymer urethane, and it sometimes will stick too well to pure glass. Now this is not pure glass. This is one of the plates that has glass with the texture on it. So it may release from that okay, but I didn't want to take any chances, so I put a little bit of glue stick on there. I'm not even sure if I had the bed heat on. Let's see. I don't think I did. Yeah, so the build plate temperature is at 0 on this. Then that's typical for TPU. So how to get all these settings? I started, actually I don't know if I changed any of them. What I did is over here in this is for Cura, in the middle, material, they have some brand names. They actually, if you go to manage materials or the add more materials from the marketplace, there are different brand names. Now this particular one is Priline or Priline. I don't know exactly how you pronounce it, but Priline. Sure, I got it from Amazon, and that was not on here. So you didn't see it. They have a lot in here, but not that one. So if you have one of these brands, then the company itself has profiles already set up for it. Unfortunately, the one I wanted wasn't there, so what I did is I just used the generic TPU 95A hardness, which is one of the, it's one of the stiffer TPU materials. NinjaFlex might actually, now to think about it, they're another one of the popular flexible filament groups. Yeah, Ninja Tech. They have a different set of, let's see what if I click on it. Well, I guess you can just armadillo filament. That's not not the one I thought. Maybe they renamed it. I don't know. No, that's a different material. Well, anyway, you can look through here and possibly find the company that made your filament already has a profile built for you. If they don't, there's these generic ones for most materials, and I use the TPU. TPU is what most of the flexible filaments are. They just come in different hardnesses or flexibilities. And doing that, now notice Cura does color it. We were at, I think it was yellow when we were on PLA. So that's kind of a reminder, because it is very easy to forget that you printed the tire in TPU and you want to print something in PLA. The color here hopefully reminds you that, wait, something's different about this. And you remember, oh yeah, I have it set to TPU. And then you go back, switch it back to PLA, because there are going to be some settings in here, like the temperature is going to be pretty high for PLA, and you could probably print faster. The build plate you might want on, so there's a lot, and retraction may or may not be turned on. And here retraction was turned on, but the settings for it might be, I didn't look at the settings. Let's see. Well, it doesn't show me what the retraction settings are, but they probably reduced them from what you normally had, because you can't retract too quickly for using the flexible filament. What happens when the filament doesn't print well is over here. I printed out a little knob to put on the extruder, but right here, the filament will, if it's having to retract and go back in quickly, or if you have some temperature issues and it's not able to extrude and it's getting backed up, it's going to come out right here because it's unconstrained a little bit. Now, a lot of these have started making this as constrained as possible, but it will not be crazy that you would see a big loop of filament just winding up over here, because it's, instead of going in here, it's actually coming out the gap between the feeder gear and the plate, the hole where it goes into all this tubing. So that happens plenty if you have any of your settings wrong, particularly if you forget to switch over to TPU settings and you're printing at PLA settings. They're too cold or too fast, and it's going to probably coil up right here. Also, TPU is very hygroscopic, so I do have it in this Sunlu filament dryer box. I dried this filament. It had been stored in a dry box since the last time I used it, which was probably 6 months ago, probably, maybe more than that. And that would, if I had left this just out in the air down here where we live, it would more than likely have gotten too much water in it, and it would just, if it printed at all, it would print very poorly. If you ever hear the sounds from here that sound kind of like Rice Krispies while you're printing, that means there's too much water in your filament, too much moisture. And it's basically boiling off the moisture as it exits the nozzle. And so if you ever hear that, then you might as well stop that print, unless it's almost finished. But stop that print and try to either find some new filament or find a way to dry the filament you have, because it's going to have poor layer adhesion if it prints at all. It's going to be very brittle when you print it. So Rice Krispie sounds from here means your filament is too wet. It's absorbed too much moisture from the air. TPU, what we're using here, is very bad about that. TPU, any of the carbon fiber type field nylons, or just nylon in general. ABS, kind of, not as bad, but sort of. PVA, if you're using any of the PVA as a support material, it's really bad about absorbing moisture. So this box worked really well. I didn't have any complaints. Basically, I turned it on, and it's basically a tiny little oven that sits there at 50 degrees Celsius, so it's below the glass transition temperature of all the spool material and the filament itself. and it just sits there at 50 degrees until you unplug it. So I left it for 5 hours or so. The recommended time, they give you a couple of little recommended times, and it said 3 to 6 hours at 50 degrees for TPU. And so I did that, and it worked fine. There was no problems. I did have a couple of problems with the print not related to moisture, but most of those problems were from me flexing it too much, like after it was printed. It was fine while it was printing, and it was fine afterwards. So let's see, just to, for one, measure our sound level when we're printing. These fans, remember this fan here is making most of the noise. Just so as an update, I did order these. Ordered 2 of these actually. So that's what I was saying. They're kind of expensive for a tiny little fan. Normally, a PC fan like this little fan is $2 or something. But the quiet ones, and this one does work with 24-volt printers, which is the main problem I was having finding other fans. And it's the right form factor. Should be the right hole sizes and everything, pattern. So I ordered 2 of those, one for the hot end cooling, and I did get one that we could put down here on the motherboard cooling, because there is a fan in there also. I should check to make sure. Remember, that was the one. Yeah, it's going. But it doesn't make nearly the noise that this one makes. So they should come in a little while. We'll put those on and see if it makes any difference. But what I want to do right now is, let's put a new print in here. That one was I would say 3.5 hour print or so. I don't want to print that again. I don't actually have a, that one came, oh, I guess I should show you where that came from. If I can find it. It was from Thingiverse, and it was from a Jeep. Let's just do Jeep. See if I can find it. If I can't find it really quickly, I'll just link. Oh wow, that didn't. Oh, that's interesting. Sometimes the search on Thingiverse doesn't work at all. Yeah, right now it's not going to work. So I'll find it later and post which one it is. The actual print is really cool. If you're into scale model building at all, or you like Jeeps, it's actually the entire Jeep is there, not just the wheel and tire. And you don't have to print the tires in flexible material. You could print them in PLA and slide them together. It'd be fine. But it's actually a really cool model, and it's all free on Thingiverse. All right, let's go to Cura, and let's open, oh yeah, that's why I was moving this out of the way, to get the file. These little guys. So these are battery holders, so like if you have 2 AA batteries, this will hold them and keep their ends from making contact with anything and potentially shorting out. So let's make sure we're on our, yes, we're on our generic TPU profile. I don't think I need to change any of these profiles. Let's make sure in here that we have our G29. Yes, there's G29 for automatic bed leveling. After the G28, we've got the 420 commented out because that's the manual mesh data that we're not going to use. Actually, there's no data on there now, I guess, unless it happens to store the data from the BL Touch, which I'm not sure if it does or not. So all that looks good. Let's print it at, oh, it doesn't have a 0.28 profile built in. Let's slice it and see how long it's going to take. An hour. Well, you won't have to sit around while I print these, but we'll get it started so that you can see the process. So now I can use the USB stick instead of having to use the little SD cards. So this one's called, what's it called? Cell caps. All right, and back over here. Again, you might can see what's going on the screen, but so put the USB in here or the SD card, or you can still use the other one. Print using, I think I clicked that. There we go, I didn't click it. All right, so there it is down there. It's got a full menu of all the stuff on this USB card drive. That one, and that's it. Now, I will put again. It still has a little coat. You can see it there actually. This have a coat of glue stick. I'm going to put a new glue stick coat down. Probably don't need to, but I'm going to put a little on there. Just because sometimes TPU has a little extra sticking to the build and it's hard to remove. So I'm going to leave it with a little bit of release agent basically. This is just a regular ordinary glue stick, nothing fancy about it. They do make some particular for this application type of glue stick. I've never used them, never had the need to. Normally I wouldn't even put anything down, but I'm a little bit leery of printing TPU straight onto any material because sometimes it just does stick too much. Unless it's a special material for printing on TPU. It's heating up. Remember, the bed's not going to be heated in this one, so it's only heating up the nozzle. And then we'll look at, give it a little round of printing, and so you can kind of see. Mainly, I'm interested in the. I don't know where I'm going to put this, but the noise level, or hopefully the reduced noise level. If I move this back, so you can see all of it. There we go. All right. Let's see if there's any other things. So what other things are coming up? Let me check on. Oh, there's a quiz coming up. So in Moodle, and for that quiz, it's all multiple choice. It'll stay open for several days, so you don't have to do it any particular time slot. Hey, there it goes. See how quiet it is? You can still hear it, but it is much quieter than it was before. I definitely hear the fan more than anything. So it's moving, probing around, and we were getting maybe 58.8 it looked like was the high. Remember, printing before, moving around before, the homing routine last time got up to 72 even, moving the z-axis. Now this one's moving a little bit slower, I think, but still. Remember, the decibel scale is logarithmic, so small changes from 58 to 65 may not seem like a big change, but that's actually a huge change in sound level. Yeah, so it's in the low 60s where it was in the low 70s before, during the homing routine. I'll let it finish its homing and then start the print, just so we can see what goes on with all that. One thing with this dryer box, I don't know if you noticed or not, but it feeds directly into the printer. So you don't have to take it out of the dryer box if you don't want to. In fact, I don't have it right now running, but you could leave the dryer box running. I don't know if you would need to. Most materials aren't that hygroscopic where they just suck up moisture instantly. There are some that are pretty bad, particularly with as humid it is here. I don't know what our average humidity is, but it's pretty high. Let's see if I can. 74 is the average humidity here. So relative humidity, average. So pretty high, and you know it certainly gets higher than that. So at that relative humidity, materials that are hygroscopic are going to suck up moisture and not print well. PLA is not so bad at that. You can generally leave PLA out for extended periods of time and not have problems. But TPU is not friendly being left out in 74% average relative humidity. So if you're noticing, it's printing now, and when I'm not talking, it's at about the same level as it was when it was just sitting there with the fan running. So, well, it's kind of off your screen, I guess, but let's put it closer. That's going to make it a little closer too, I guess. So about the same as when it was just the fans only. Maybe a little bit louder than just the fans only. I guess I need to fix this in a certain position so that we can get some more scientific. This is very unscientific measurement, but at least it's an instrument to measure the sound level instead of just me telling you that it's quieter. Also notice that all I did to switch from this bed to this bed is this one's magnetic, so I pulled it off. I put this one on not magnetic, so I held it on with 2 binder clips, and that's it. When you have the automatic bed leveling sensor, not only does it account for warped beds, or maybe you got a corner that's a little bit high. Now you want everything to be as flat as possible to start with, but maybe you have a little bit off, but it makes it so much easier to change out your build surfaces, particularly when they're different thicknesses. So I've got the glass build, I've got the PEI sheet. Maybe you want a PEI sheet, but you want a textured one, and they're all different thicknesses. Instead of having to get your nozzle height just right every time, you just put the new sheet on and let it go through the homing routine. Now it does take those extra, I don't know, 2 minutes maybe to actually probe the surface. As long as you're willing to wait the extra 2 minutes, then it's pretty nice if you plan to change build surfaces often. Now, if you don't plan to change build surfaces and you've made it a hard-mounted bed and everything, the manual mesh is probably better in that case, assuming you have a way to remove parts without like scraping them off. If you have to scrape parts off, then there's a good chance that you're going to change the levelness of your bed, and your mesh data would be no good at that point. So it's really nice to have hard mounted or rigid mounted. It's still silicone, but rigid mounted with the bed level sensor, even for these smaller beds. When you move up to a printer that's larger than this one, say you go to the Ender 5 or CR10 or something where the bed is 1.5 times this size, you almost have to have some type of bed level, because automatic bed leveling, or at least the manual mesh, because the beds are just so huge that there's no way they're going to stay flat. And you probably have that giant bed because you want to print really big parts, and it's almost impossible to print a really big part, get the whole thing to stick without mapping the bed and taking that warped shape into account. Whether or not it's heated, it could just be warped from being not flat sheet of whatever you put on there. If you don't want to do this, you do want to have big sheets, then at least print on glass. But a lot of people print on a mirror, so that mirrors typically are pretty flat on the top. Plus, some mirrors have a aluminum coating on the back. That's what makes them reflected, aluminum or silver coating on the back, and that helps conduct the heat a little bit into the, if you're using a heated bed. And you don't have to get a special printer surface. You can get a mirror from IKEA or a picture frame from Walmart and print on that, assuming you can cut it to the right size. Okay, so it is fun printing with these flexible materials. They give you some new options. Hopefully you get some better color combinations. This is hideous, but they do give you, and again, you can make much more flexible than what I've made here. This one, just with the geometry of it and 2 walls, 4 top and bottom layers, it does make it pretty rigid, and this is one of the more rigid TPUs. If you want to do the softer TPUs on an Ender 3, then you're probably going to have to print a good bit slower, maybe in the 35 to 40 millimeter per second range. Turn off retraction entirely, which might make it more stringy if you have your softer materials. A question. I'll be in my Zoom office hours today at 1. I think I have Zoom office hours today at 1. Pretty sure I do. Let me make sure of that. Yes, 1 to 3 I'll be in Zoom on the office hour link, which should be in Moodle. Let's see. And I'm about to go to Zoom just in a few minutes, just for questions about this class or about other things. So in just a few minutes, I'll also be there. Again, in Zoom. I won't physically be in the office. This thing is printing well. I don't know a reason to sit here and watch the rest of it print. It's actually printing really well. Next time, I'll show you if it actually fits at AA batteries. I didn't try to scale it or anything to make sure it's the right size, but hopefully it actually works as what it's supposed to be. Next time we're also going to go in and let me check what we're doing next time. I think we're actually working on maybe some part finishing techniques. I think. Yeah. Oh, and casting parts. So in next time we'll do a couple of things. They won't necessarily be related directly to 3D printing, but after you've made a print, what are things you can do with it? So we'll look at a way that you can cast a part. How is it going to be too complicated, or is it actually pretty simple to do? And then some part finishing. Maybe you want the part that you printed to look like another material, and there are some things you can do to work on that. So it'll be more of a overview of a couple of different processes. Next Thursday, we're going to install Octoprint on our printer. What that does is you would need a Raspberry Pi if you want to do this. So a 3 or there's a 4 now. So one of the more recent Raspberry Pis, and it will let you talk with your computer wirelessly. So you can actually log in on your phone or on the internet. If you're on the same network, talk to your computer, start up prints, monitor prints. One of the cool things you can do is set a time lapse, so that you set a camera there like a webcam, and it periodically takes pictures and assembles them into the time lapse of your print. And it can coordinate with the printer so that the print head is always off to the side when it takes a picture, and make it kind of nice. So we'll do that on Thursday. So that's what's coming up. I'm going to go over to Zoom, and if you have any questions about stuff, I'll be there for a bit until 9:30 or 40 or something like that. And I will see you guys next week.